So in this video we're going to go over the double for loop. So this is used to make this plot. What you notice about this plot is that the rate changes across this way, the principal changes this way. So this is an example of one for loop that goes over rate, rate, rate. At the same time it's going over principal, principal, principal. So if we look at the code here, run to here. Here's our p-value. So unlike before, our p-value is actually 3 values now. The other thing we've done is we've pulled out iPlot index separate from the loop variable for the rate. So if we step over this, when we draw here, this says we're drawing 3 rows, 3 columns, and we want to start with the first plot. We're going to do the first rate value and the first principal value. So we call our function and we plot. And if we look at our figure, we've plotted the figure for the upper left-hand corner. So we'll step through this loop again. This little bit of code here is designed to make the y-axis all the same. If you don't make the y-axis all the same, this would be plotting this way. It would be really hard to compare. So what this is doing is it's saying make the low y value this one and the upper y value that one. So we've incremented plot index by hand. We've had to do this by hand because it is no longer an index variable. So now we're going to plot 3 rows, 4 columns, the second plot. And this time we're going to have the same principal value we had last time, but the next rate value. So when we plot, we get the second one of these. So you'll notice here that we have this like this. When we step over the rate, the y-lim, it shifts the y-axis to be this. So it's the same plot, it just changed the y-axis. That way the y-axis on this one and this one are the same. So we'll loop through again, plot the third one of those and the fourth one of those. Now at this point, we have tried all 4 values of r. Right? Because r has 4 values. So what we're going to do is come out of this inner for loop, and now we're going to do the first of the second for loops. So I try p just got incremented to 2, and right here, so you notice I try r is r, when you step it gets set back to 1. So we've made one whole row of plots with the different rate values and the same starting principal value. Now we're going to start the second row. So see, we started the second row. And we just keep doing this for the remainder of the times, and we end up with this plot. We're now going to make 2 changes to the script. We're going to save the data that we calculate, and we're going to use MATLAB to find the point when we hit our target goal of $12,000. So I've made a couple other changes here which are just cosmetic, but which I call visual type checking. So any variable that is an array, I've changed to have an S value at the end here, and these will be 2D arrays. That way we know that this is actually an array of values and not a single value. So other than that, the beginning of this is exactly the same. Here, what we are doing is we are making our variables to save our data into. So we've used zeros before many times. What's different here is that I've set this to be the number of elements in P, this to be the number of elements in R. So this is going to have enough space to put every value of P and R that we calculate. This trick here just says make me another variable that is exactly the same size as target. So size, if we go look at the command window, it's like length except it's for 2D arrays. So it returns 3, which is the number of rows, and 4, which is the number of columns. So if we type when target, as we saw before, it's 3 rows and 4 columns. So we make a variable to save P, we make another variable to save R, and again we set our number of rows to be however many elements we have in P and how many in R. And here's our anonymous function again, and here's our loop. Now they've done one other thing. So because this is now an array, and I know that I only want to use one value of P when I go through this array, what I've done is I've just declared a variable p, which is the principal for this time through the loop. And I've done the same thing for R down here. This just makes it a little bit easier to use P and R instead of having to type the PS with the index in here. Now here's where we're saving the values. So every time through this loop, we're going to save the value of P and we're going to save the value of R, and we're going to save it in the correct place in this matrix array. Now this has to be here, not out here, because we need every possible value of P and R. So there's our subplot again. All of this is the same. This up here is actually a little bit different than I did before. So this is just that red line that gets drawn across. And you'll notice here that what I've done is make an array that has two elements in it. It has the first value of t and the last value of t. I know this is a straight line. And I've set the height to be target. So this draws my straight line. This is where we ask MATLAB to tell us when we're going to hit $12,000. So this function here is another anonymous function. It calls interest anonymous function with the current value of P and the current value of R. And it says, find me the t. We can vary the t. And then we subtract target here. Now the reason we subtract target is because the function we're going to use is f0. So f0 finds the 0 of a function. So the way to make this function be 0 at our desired target value is to subtract off the target value. So right here we're going to ask f0 to go find the point at which this function is 0. And f0 is allowed to change the t value here. So we step through and it says the t value I found where this function is 0 is at 16. So I'm going to save that. And then I'm going to plot what it found. And you'll notice I'll plot the t value here. And then I'll take my original function and I'll call it with my p and my r value and the target value that I got back. And see here, this is where this line is going to intersect the 12,000 line. So this is the t value where we will finally make $12,000. One other thing to note, so I said that in general the fact that MATLAB lets you do this, so it's going to grab the p value that's set in this for loop and the r value and the target value that are set in this for loop. The fact that it does this is really useful right here because we're essentially binding the value of p, r, and target within this function and then only letting t variables. So this is what anonymous functions are used for, and this is the only case where you actually want to use variables that already exist instead of passing them in. So we do this many, many, many times for all our different values of p and r. So when we're done, we are going to save out our p values and our r values and our target, and we will save those out to files, just like happens in the teacup. So if we go and we look in our directory now, we've got the r values, the text values saved out. So here, for example, it's the p-value saved out. And you notice that it says 9,000, 9,000, 9,000, 10,000, 10,000, 10,000, 11,000, 11,000, 11,000. Just like if you look at the plot, p-values are the same this way and vary this way.